See, interference, like to check the surface topography, that is applied to flatnet testing, that is formation of white and dark interference fringes. Here we'll use the monochromatic light. Can you see this optical surface here? Right side, one optical surface. Yeah, optical surface. We use monochromatic light, and then an optical surface we'll use. Okay, this optical surface and the monochromatic light. First, you can just check the here nominally flat surface. This is the working surface. Okay, nominally flat surface, right? And then optical flat. How the optical flat have been placed? See, one side it is contacted, right? And the other side there is no contact. There is a gap, air gap between the working surface and the optical flat. So this gap is, that is angle is theta, that is optical surface and the nominal flat surface, that is angle theta in between these two surfaces, right? A monochromatic parallel beam as incident on this optical surface, and then see A is the incident, A is incidenting, that this S first ray is incidenting on A, and then part of which is reflected, and part of which is transmitted till B, that is it is reaching the working surface, and then one more ray which is coming, and then again it is moving. You can check, right? So if it is a what constructive interference, it would have happened the what white fringe, but here what which fringe is happening, which is the dark fringe. And then one more ray you can check, that is yes, that is it is falling on the optical surface D, there it is incidenting, and then a part of which is reflecting and a part of which is transmitted, and then it is falling on the working surface, then again it is reflecting from the working surface, right? So here also it is out of phase, right? That is why destructive interference is happening and the dark fringe is producing. If see in the red color we have drawn, like if it is a constructive interference within the phase, then we would have got the white fringe. So like this, there should be the air gap between the optical flat and the working surface. Otherwise, will not get any fringes. Okay, understood this? Next, we'll just check how this dark fringe and bright fringe happening in this. Right? Can you check this? See, this is the destructive interference. That is, see, the down odd multiple of lambda by 2 and even multiple of lambda by 2. This is the working piece. This is the working piece. And the black, that is dark surface, is the air gap between the optical flat and the working piece. That is this, the bright colored it is, that is the optical flat, air gap, air cushion, and the work piece. You can see these three things. And then odd multiple, when destructive interference happening, see, check this, it is out of phase. You can check the fringe, it is out of phase, so you are getting dark fringe. And then one more side, this side it is, see, it is in phase it is. You can check the waves, small waves, they are equal, both the rays are very much equal, their amplitude, wavelength, everything is equal. So constructive interference happens, and then you will get a bright fringe. That is, when it is even multiple of lambda by 2, you will get the bright fringe. When it is odd multiple of lambda by 2, you will get the dark fringe. So next we'll see how we are analyzing due to this fringe. What tells this fringe to us, right? When if angle theta increases, fringes are brought closer together. Check this. This is a theta, one is the normal fringe. Okay. When the surface is good enough, that is, it is flat, so we'll get the normal fringe. That is, theta increases. If the angle theta increases, fringes are brought closer together. See this theta 2 in this figure, you can check when angle between these two is increased, that is the fringes are becoming close to one another. And then if theta is reduced, check in theta 3 figure. In theta 3 figure, if the angle between optical surface and the working surface is reduced, so in theta 3 we'll get the what distance, there is a more distance spacing in between the fringes. If there is no angle, that is optical surface and the working surface are flat, if both are flat, there is no angle between them, then we'll not get any fringe. Okay, like this, due to these fringes, we'll check the what surface topography, whatever the roughness or the wavy nature, whatever the nature on the surface, we'll check all these things. Due to this, surface topography can be checked in multiple beam interferometry.